In this video, we are going to learn about climate feedbacks. We are going to learn what is a climate feedback and why it is important. Then I'm going to present some examples of key climate feedbacks and then at the end, a concluding remark. Let's imagine this box is our climate system. Now, if we have a given radiative forcing as the input to the system, the equilibrium temperature change or the response can be related to the input forcing by a parameter called climate sensitivity, which shows the sensitivity of the climate system to the change of its radiation budget. Now, in order to understand the functionality of climate feedback, imagine we have some feedback in the climate system. Then some portion of the system response, as shown in this figure, is returned to the input and causes additional forcing and thus additional response. In this case, depending on the sign of the feedback, it can further amplify or weaken the response. So we call it a climate feedback if the response of climate against change can induce or reduce further changes. Feedbacks can be positive or negative. Here we have an illustration of a positive and a negative feedback. Basically, a positive feedback cycle is a cycle where the effect reinforces the cause. This means the impact will go on increasing. Whereas a negative feedback cycle is a cycle where the effect resists the cause. This means the impact will go on diminishing. Now, why climate feedbacks are important? Well, first of all, they can change the radiation budget of the Earth system. Therefore, they can add or reduce global warming, although overall, based on the current estimates, they add to the warming. Finally, the more we understand about them, the more confidence we have in our climate projections for the future. The better the projections, the better we can understand the extent of climate change, and therefore we can better prepare for it. What are some important climate feedbacks? In this video, we are learning about 3 of them. Water vapor feedback, which is a well-understood positive feedback, ice albedo feedback, which is a well-understood positive feedback as well, and cloud feedback, which is a poorly understood feedback, and depending on some cloud characteristics, can be a negative or a positive feedback. Water vapor feedback. Now imagine some warming scenario. As air gets warmer, we have more evaporation of water. Since water vapor is a greenhouse gas, it helps in further warming the climate, and this amplifies the initial warming. From what we learned, this is called a positive feedback. Ice albedo feedback. Albedo is the amount of light reflected by a surface, which is very important in climate science. A surface with a high albedo, such as snow or ice, will reflect more sunlight back to space. Therefore, the higher the albedo, the less energy and heat is absorbed by the surface. Now, let's go back to our warming scenario. Under a warming climate, we have more ice and snow melt, and this reveals the land or ocean underneath. Land and ocean are darker surfaces compared to snow and ice, and therefore, they absorb more of the sunlight and reflect less. So as the ice melts, more of the sun's energy is absorbed, and so the planet gets warmer, which in turn melts more snow and ice and amplifies the initial warming. From what we learned, this is called a positive feedback. And finally, cloud feedbacks. Under high warming, there will be more evaporation, which can result in higher cloud. But it's unclear what is the strength of cloud feedbacks and whether they act as a positive or a negative feedback. In order to understand why clouds can have both positive and negative feedback, we have to understand how they respond to an incoming radiation. Clouds can receive 2 different types of radiations, solar radiation and terrestrial or so-called long-wave radiation. Typically, clouds increase albedo and reflect incoming solar radiation and act as an umbrella. Cloud can also receive incoming long-wave radiation from the Earth's surface and act as a blanket that keeps the Earth warm. Let's explore what determines a net cloud effect, or in another word, what determines whether a cloud has a negative or a positive feedback. Clouds, due to their reflectivity or so-called albedo effect, reflect incoming solar radiation and therefore reduce the radiation that reaches the Earth's surface as indicated by the yellow arrows in the picture. Therefore, relative to a no cloud condition, they result in cooling effect. So with respect to solar radiation, when there is more cloud, there is more reflection of solar radiation back to the space. This results in more cooling, and cooling results in less cloud. So this is a negative feedback since it diminishes the initial change. On the other hand, clouds absorb outgoing long-wave radiation from Earth's surface, then emit a portion at a cooler temperature and emit a portion back to surface. So they basically trap a portion of the long-wave radiation, as indicated by the red arrows in the picture. Therefore, relative to a no-cloud condition, they result in a warming effect. So with respect to long-wave radiation, when there is more cloud, there is more absorption of long-wave radiation. This results in more warming, and warming results in more cloud. So this is a positive feedback since it amplifies the initial change. Now, what is the net effect? The net effect of clouds on climate depends on clouds' type and their optical properties. In general, high clouds tend to produce a heating, positive feedback, and low clouds tend to produce a cooling or negative feedback. Concluding remarks. Hopefully, this lecture provides us for a better understanding of climate feedbacks. While we understand many of the climate feedbacks, we don't fully understand all potential feedbacks, so uncertainty will continue to exist. But how a better understanding of climate feedbacks can help? Well, a better understanding of climate feedbacks can help us to better understand the mechanism of climate change and also helps us to select important processes and limit the complexity of climate models.